All right, thank you. Welcome. I hope you had good coffee because I have a lot of code that I want to go through in this talk, but let's see. So welcome. My name is Jignash. I've been working with Postgres since 2005. In my previous incarnations, I've done Postgres on Solaris, benchmarks, tuning. After that, I actually worked a lot on Postgres on virtualized infrastructures, trying to get people using databases on VMware instances. And now, for the last 2 years, a little more than 2 years, working on getting Postgres to the cloud and heavily being used for production reasons, right? So what do I do now is lead the engineering team for RDS Postgres. And my talk is going to be about extension. But before I talk about extension, I want to talk about Postgres Core. Now, Postgres Core, as we all know and love, has been a database for more than 25 years now. The core actually gives you the bulk of the features, right? It gives you the MVCC features, it gives you the standardized SQL queries, everything. Now, what happens is the core is released every year, and you get a lot of new features. But a lot of times you see, like in the Postgres ecosystem, people also want some features faster than how it gets integrated into core. And you'll see that, right? People come up with new features, they want to release them so people can try them out. People evaluate them and see how they are using it, and actually that actually forms the basis of what are the next set of features that goes into core. So this is where we come to the topic, which is extensions. Extensions are basically a set of functions which you can load into standard Postgres and allow you to extend the features that comes out of the box from the core Postgres. What does it provide? It provides new data types, it provides new functionality, it provides new operators, it can be anything. It can be even changing the existing behavior of a function that you are using. It can be, practically, it is something that you can say, I want to customize my Postgres to a level that I need it for my job, and I can do it. So that's the power of extensions. What we are going to do is look from a user point of view how extensions work, and then we actually go into a developer view on how you can actually develop your own extensions if you want to do that. To create an extension, basically there are quite a bit of very simple rules that you will need to follow, and basically the primary ones would be a control file, schema or something that you want to say on how your extensions are defined, and if needed, any modules, right? So how are they used? So I want to start with first examples of extensions that you would see out there. The most common one that you would see that I've seen people using a lot would be, hey, I want to do spatial functions on my database. I need something that allows me to do more spatial type of features, right? This is where PostgreSQL comes in. If you talk to DBAs, hey, I need something to kind of query what are the long-running queries or how my queries are performing. pgstat statement is actually one of the most popular extensions out there for this type of things. And there are extensions which actually completely gives you a new kind of feature, like Postgres FTW. It actually allows you to do federated support in Postgres, allowing you to talk to other databases and do queries across multiple databases. Similarly, if you are not familiar with SQL and you want to take your own languages, there are extensions like PLV8, which actually gives you can write your stored procedures in JavaScript. If you are actually more of a web user, I think UUID is one of the most popular extensions I've seen out there. In fact, most of the Ruby, Golang, and other things, anytime you use an ORM, the first thing they say, hey, I need a UUID for every table that you have because I'm going to generate a unique ID for all of them. So these are the power that Postgres gives you by allowing you to write your own extensions. The first thing I want to do now is actually go over how a user lifecycle of an extension goes. Typically, when you get a Postgres instance, you don't know what extensions are available for you. there is a nifty view out there, which is called PG Available Extensions. you could actually just query them to see what extensions are available on your particular instance, especially if you are a user. Now, mind you, like if you download Postgres from the website, do a make, and start using it, you will not see any extensions out there. Typically, you would have to do like a make contrib and then install the extensions. And then when you install the extensions, you could actually use this particular query to see if they are available now on your instance or not. There is another view available also, which is called PG available extension versions, which allows you to see detailed versions or multiple versions of a same extension. Like PostGIS, you could actually be running on 2.0, 2.1, and multiple ones. And oftentimes you need multiple extensions for, say, if you're doing an upgrade case, like you have upgraded from an old extension to a new version. We'll talk more about that in following slides. To start using an extension, you would start with the same familiar command that you would do with anything in SQL, right? You would do create extension. The example I'm showing out here is pgstat statement. Once you use this command, you have to remember extensions will be tied to a specific database in your instance. So if you have multiple instances, this extension is only created on the database that you are connected with. This is irrespective of the functionality that the extension provides. Like for example, pgstat statements will be querying everything that is running across multiple databases in your instance. But if you kind of like look on how you have installed it, it is only installed on a specific database in that instance. How do you see what extensions are installed for your databases, right? So there is a nifty view again. You just do select star from PG extension, and it will show you what extensions are enabled for your database. Now, this command is, you have to take care. If you have 5 databases running in your same instance, it would depend on which database you have connected to, and it will only show you extensions enabled on that database. So if you create an extension on, say, database Postgres and create MyDB1, and if you switch to MyDB1 and do a list extensions, you may not see them. So what the right practice most people would do is they would enable it on the database that they're going to use it for. And most of the time, only based on the type of extensions, only that database would be able to use those functionality. So this actually gives you more powerful feature, right? Like if you're actually consolidating multiple databases into the same instance, you can still have different extensions enabled for different databases. So like if you're a SaaS provider and you have databases by customers, you could actually have a uniform extension across all of them, or depending if you're doing multiple applications on the same instance, you could actually have databases with 5 extensions enabled on one, while only have like 1 or 2 on a different one. So it kind of gives you a power on how you deploy it out there. The next thing you would typically do a lot is over a period of time when you kind of upgrade your Postgres versions, you also would be upgrading your extensions. There is a command called alter extension name update, which will upgrade your extension. Now, this is where I think sometimes update is a misnomer out here. It's not really updating the data, it's actually upgrading your extension. And then in the same way, if you're no longer using an extension, you could actually drop an extension from that database. Now, this is where I would generally put a caution. There are 2 ways you could drop, right? You could drop extension cascade, which typically would be an unsafe way to do that. This would actually drop all the data objects associated with an instance and can lead to a data loss. So if you're really not sure about how the extension is currently being used in an in a particular database instance, never do a cascade drop, because you don't know what you will be dropping at that point of time. A safer way would be just do a drop extension name. If there are objects dependent on it, it would warn you that it's being used. You should actually investigate to see what those are being used for and see if it is safe to drop them or not. This would be a good way. I've seen people fall into this pitfall of doing, oh, I'll just do a cascade and then say, oh, I lost some data somewhere. And that would be hard to kind of retrieve back then without doing like a restore. Okay. There are a few more things actually available in Postgres, which sometimes are clubbed under the extension framework thing. But they are actually, they behave differently. So one of the other most popular ways of using new functions is called loadable modules. In case of loadable modules, they are same as other functions that you would typically use in an extension, but they are not something that you would use like commands like create extension. You just start using them. They would be automatically loaded as required. This can be functions that you write in your own language, like say C, and want to use them in Postgres. You could actually just create a function with language C, start using them. The first invocation of that would automatically load the module from your file system and start using them. There is also a load command given for that. So if you are actually doing something which would actually cause to change a default behavior and function differently, then you need to do an explicit load to kind of load those functions. Because like as I mentioned, it only loads it the first time you interact with it. But if you want something always to be running anytime, it doesn't matter whether it's in your session or somebody else's session, you have to use the load module. And in order to kind of make sure that everybody sees that, you could actually set them in the shared preload libraries, so you can make sure it's always loaded for all your sessions, right? One thing I want to take care about is like the user rights on who can load these modules depends on the type of user. Super user can load it from any directory, which means you can actually position and say, I want to load it from this particular directory up there. But if you're not a super user on an instance, you can still load modules which are in the plugin directory on your setup. So you need not always be a super user to load a module, but you can only load approved modules which would be in the plugin directory. Now, again, like I said, I'm using different terminology. I used a terminology called extension, then I used a terminology called loadable modules, and now I have something called plugins. And that is something that you won't probably realize it, but plugin is actually another kind of thing, which is called the decoding output plugins, because they also work similar to extensions to some degree, but they are very specific purpose. Their purpose is to kind of track all the record changes, wall record changes, and give it into a way that you can consume it for your output, right? Starting from, I believe 9.4 is when test decoder was included as an example, where you can start tracking changes that are happening in your instance, and you can use that to apply to a different instance. Right now, there are more examples of that available in the wild. There is decoder raw and also wall2JSON. I've seen wall2JSON as being more popular, like people using them for tracking database changes and then pushing it to Kafka pipelines. They use them to push it to a different type of databases also. So as of now, what we have seen is you essentially have three forms of custom code that you could do. One is extensions, one is loadable modules, and if you want to kind of do something specific to the replication area, you would have like an output plugins that you can use. In the remaining talk, we'll be talking more about just the core extensions, like which is the piece out there. The remaining sections will be about how you can develop your own extensions, right? The most simplest example of extension would be the SQL-only examples. In an extension that is only SQL-only, you only write SQL code, and you could add them as new functionality in your database. For example, people write multiple functions related to how strings are manipulated. You could take multiple of those functions, package into an extension, and provide that as a new package available. To do that, you basically just need two files out there. you need the definition of your function, and you need a control file, which kind of explains how that's worked. In the SQL file, it would be a function definition, and I've shown you a simple example. All it does, it defines a demo version and gives the version number out. If you look at demo.control, this is where it becomes interesting. The demo basically has a comment which kind of gives you like what that extension is doing. It gives you what's the default version. Like I said, extensions can be versioned, so you can actually control them for upgrades. So you say what's the default version, and there is the other field called relocatable, which in this case I've set true. What relocatable does is it gives a control like whether the functions or the objects that I'm creating as part of this extension can they be moved to a different schema or not. Most of the time, you would allow them to be relocated. If you want a tighter control, you would say no, because that way you actually have a way when you're doing upgrades, you have full control on where those objects are located. And then very simple, all you do is copy them to the share extension folder of your installation, and boom, the extension is available to you. You could start using them immediately. You could just create the extension and then just run the function. You would see that, right? Let's go to a little bit more complex example where, say, I now want to rewrite this function in C. The way you would do that is you would actually change the definition of your function. Out here in this case, you would see what I've done is I'm changing the definition of the function to load it from a C function using the language C. And then I'm changing my control file and just giving me a module path name to say where that module will be loaded from. At the end of the day, these are all shared libraries on the system. And it would be loaded, like what's the name of that shared library that would be needed to execute the function. Then you can write that same function now in C and use that. And this is where I think the Postgres extension framework gives you a very good way that you don't really need to re-implement everything. Everything has been given to you in the form of macros that you could readily use. In essence, you actually only need like two main macros to use. One is the module magic, which kind of puts a magic block to identify the versions and other things for the extension that you're using to make sure that these are kind of accepted extensions that can be trusted. And then there is another macro which allows you to just kind of define the functions that is coming from it. And it has been macroed to a level that when you define this function, it kind of does the back-end work of kind of creating the stubs for you in the back so that when you kind of come from the Postgres core back-end function to your module, everything is predefined for you. And then you just have to worry about like, hey, what does this function do and respond back. All your arguments would be available in this macro function arguments. And when you return back, you just need to create some return like data type. And you just give the arguments back for it, right? So I'm just showing you a very simple example where I re-implemented that select version to be implemented in Postgres, where now instead of the 0.9 version, I'm now going to give a version 1.0, right? It's very simple. That's all it does. It changes the version number from 0.9 to 0.1. Now, once you have created this, you basically now need a Makefile to kind of deploy this, right? The Makefile also comes as a pre-install. Like if you take an example from the contrib modules, you could start from one of them. The Makefile itself is all macro-based. So in your case, all you have to do is just make sure that the 4 fields are populated, and you kind of give like a extension name, what's the library name, what are the files that needs to be included as it is, and a description of what the extension does, and the rest of it is just the stub. And then you could just say, make use pgxx1, which is like use the extension module, way of creating the files. And the resulting thing will be a C shared library. of your function. And when you do a make install, it would automatically install in the share extension folder. So everything is made ready for you. And this is how you could actually just quickly start creating a new extension. So assuming I just do the same thing, I created those C file, I do a make and a make install using this Makefile, the extension would now be available for you. Now, in this particular example, I'm kind of showing you, like, hey, I already had created something demo, which was 0.9 version, and now I have a new version available. I want to use that one. Even though I have installed it, it won't be used by it because you're still referring to the version which was 0.9. So in this particular example, what I'm doing is I'm showing you the most simplest way. If you don't have an upgrade script, how do you kind of upgrade the extension? You essentially just drop and recreate the extension. And now, because the new control file is saying 1.0 as the name of the version that would be the default version, it would use this --1.0 definition out there. So when I come back here and I create an extension again, it's using 1.0. And when I run the function, I would see that that's the one that's being used. So this is one way I'm showing you on how you could actually do an extension. When you create a new version, you could essentially drop the old version and recreate it and get to the new one. Now, what I had shown you was like kind of basis of an example, right? In my first example extensions I had shown you, you could actually write more complex extensions. For example, if you want to write like a foreign data wrapper. Postgres actually makes it very simple for you, right? If you look from a point of view for a foreign data wrapper, if you want to define a new one, you need two functions, which is a handler and a validator. Think of it always, a validator kind of validates, is everything okay? And the handler is actually an executioner, which will actually go and perform the task. And in the Postgres, similarly, all you have to do is you could write your own C functions using and create like a handler and a validator. And if you have that, and of course, I'm not going to go into depth of this, but essentially, in the handler, you have to define multiple functions for your access plans, how you execute them, and everything. And when you come back to Postgres, you could just write, create a new foreign data wrapper and club all of them as a new extension. And you could have your own custom FDW driver for it as such. So that's one way you could actually use and write your own extensions. Similarly, I also mentioned you could actually use it to write a new language support for Postgres. And it's kind of similar out there. In your extension, you would actually have 3 new functions and then define a new language in Postgres and use that in a way to kind of support a new language. Out of the box, Postgres actually has support for Perl, Python, and there are extensions available even for Java out there in the world. But essentially, if you look underneath each of these extensions, they have 3 main functions, which are the handler, inline, and validator, and use that as a way, and using the extension module, you could actually implement them. So this kind of shows you the power. You could go from a very basic function to all the way writing new language support or new data wrapper, foreign data wrapper support using the extension framework. It's pretty powerful. One thing I want to spend more time is actually how you should be thinking about doing upgrades for extensions. Oftentimes we get lost. Like, I want to do the greatest feature again and again. I keep on iterating and creating new, better functionality. But if you look from a customer point of view, they are users of it and have years of data on it. So once they start using your extensions, you need to give them a path for doing a proper upgrade, right? One thing I mentioned in my earlier slide is like you could do a drop and recreate an extension, but if your extension is a data type, in order to drop the extension, you'll have to drop all the objects, which is loss of data, which you never want that to happen to your database, right? So how you should be writing extensions that are a little bit upgrade safe, right? One way to do that is always have backward compatible APIs as such. So whenever you want a feature that is going to break or behave differently, you want to version them. And you always need to make sure that you can still support the older version as well as give them a path to use the newer version. So in this particular example, I'm actually showing you an extension where I'm going from 1.0 to 1.1, which I say is actually having completely new way of doing things. It may not be exactly same as the previous version as such. And in order to kind of do it safely, what I'm doing is I'm actually defining it as a new function name within that definition that I'm doing. So for the purposes of this demo, I'm saying I'm doing demo 1.1, which is different than my original demo function. Now, by doing this, I have now backward compatibility. Like my same distribution, I can use the older version and also use the newer version. And then how do I make the users go safely from the older to the newer version, right, for an upgrade scenario? In extensions, you actually have what is known as an upgrade path. You can go from an older version to a newer version, and you can define the diffs that would be happening. So in this particular example, what I'm doing is showing you an upgrade path. In the upgrade path, what I do is I do a create or replace and give a new name for the user. In this particular case, I think all I'm changing is the function definition. So I dropped the original demo version, which was pointing to demo, and recreating it by pointing it to demo 1.1. So as soon as I do the upgrade, now people will see the new version. But if you're still on the old version, they will continue to do the demo. So from a developer point of view, if you still have bug fixes and other things, you can still provide them for your original version. But if you have like new functionality that you want to have like a different user experience, you would actually force them to kind of use a new function name. And again, the make files and everything, it's kind of simple. You just add those two upgrade paths. I'm actually doing it for both 0.9 to 1.0 and 1.0 to 1.1, a similar way. And once I'm done, boom, I do make install. And now actually I have an upgrade path. And how do I initiate the upgrade path from the command line? You would use the alter extension update to. Now, one thing I hadn't mentioned earlier, it said you could use alter extension demo extension name update. When you just use the update command, it goes to the default version in that release. But if you want a very specific version in your extension, you would say update to and give the version name as text field. In extensions, all versions are text field because it doesn't really necessarily understand what is 1.0 or 1.00. It basically uses your upgrade paths that you're setting and just executing from the old version to the new version that you are seeing. So from the framework point of view, it doesn't know what's a minor version, major version of extension. It basically says, I have an upgrade path from going from here to there. And that's what it would start executing. So in this particular example, after you do like a demo upgrade to 1.1, if you look at the demo version, you're seeing 1.1. Now, come back and think about it, right? If I had done bug fixes, they would still be in demo. And now, when you have new bug fixes, you essentially just have to reboot and reload them functions again, and you will see your bug fixes in effect. So there is no change for that. But if you want to kind of give a new functionality, the users would explicitly have to do an alter extension demo update. So that's when the new functionality is enabled. And this is what you would typically see how extensions would behave when you are upgrading your Postgres versions also. Because what happens is, when you upgrade your Postgres versions, your extensions are not upgraded. Because extensions are tied to specific objects in the database, which may be pointing to specific versions of what those modules will be loaded from the disk, right? So when you upgrade, you want to kind of now iterate, are there new versions available? Which is where you would go back to PG available extension versions and see, hey, is that new functionality available? Do I want to use them for this version or not? Nothing forces you to use them. But if you want to get new functionality out, you would then do an alter extension update. And you are now kind of moving your objects pointing to the old version to the new version. and that functionality will be then unlocked for you. So if you are heavy users of extension and you do major version upgrades, this would be an additional step that you would do after your upgrades to make sure your extensions are also now getting to a newer version. This is a way of a standardized approach that you would do. Like, when you think about upgrading major versions of Postgres, how does it impact your extension versions? What care you should be taking care of? Like, your primary motive is during an upgrade, never lose any data, right? So you have to give them path. Like, what if the customers are already using data on the older version, what's the path for them to bring them to the newer version of extension? So that's the right way of doing things. Now, let's look at, if you have multiple extensions, how do you figure out what would be working for you? Now, remember, if you remember my slides, you would see that demo extension paths are from one path to another. The extension framework is great. What it does, it chains all of the different files you have and gives you a path from any version to any one as long as those files exist. And how do you see them from the system? You run this update path view and give an extension name. What it essentially does, it queries and checks for every upgrade path available in the system and shows you. And now you can see on your setup, like, is there an update path that I can go from this particular version to the new version that I have? It may happen, some of the extensions may not give you a path, in which case your only choice is to drop the extension and recreate them. And it's not bad to do that, except you just need to take care that there are no objects depending on that extension when you drop them, right? And this also kind of gives you a counterexample. The extension framework does not understand upgrades or downgrades. So essentially, you could actually have a path going from a newer version to an older version also. And as far as the extension framework is concerned, it's an upgrade path for you available, which means you could actually, if you want, you could also give a downgrade path if you want customers to go back to an older one, right? Now, so in essence, like, I use the word customers because all my users are my customers. But if you kind of look at your own deployments, you could actually do the same thing. Like, if you have your own custom extensions, you could actually have a path that gives you an upgrade path. Oftentimes, people will ask for, like, rollback plans or downgrade plans. You could do the same. In the extension, you just have to give the path where you say, I'm going to drop the extension using the newer version and go back to the functions using the older name, and that would be your downgrade path. All you would do is, instead of 0.9 to 1.1, you would create demo-1.1-.9 SQL file and give you a way to go back as such. So this is kind of like what I really love about Postgres and how it gives you this framework. The framework gives you a way of managing an upgrade path, and it gives you a way of actually defining new functions for you, right? Yeah.
How do you find out the dependencies for
Right.
any extension?
So the question is, how do you find dependencies of your extensions? Extensions can require another extensions. That could be something out there. One of the things you could do is, if you go back to the control file, there is another keyword called require. And in require, you can put other extensions that you would want for your extensions to be present, and you would add them out there. And when you deploy it, when you create an extension, because you have a require, and if that extension is not installed, it will say cannot create extension required. And if you use that and actually say, I'm going to create an extension with the cascade function, then it will also install the required extensions as part of your extension. So you could actually use that. I should have probably added that as a slide, but that is the way you would do that. So the keyword for that would be the require in the control file. Okay, all right. Cool. Now, what we had talked about, like, creating new functions, doing an upgrade path for your extensions. Oftentimes, what it comes is like, you come that I need some predefined variables, and you want to give that control to your users out there. So how do you do that? In Postgres, everything has a tuning knob out there. Postgres loves tuning knobs. There are like more than 250 tuning knobs available. You are writing extensions for Postgres. So the first thing you want to do is have more tuning knobs for your extensions too. So the same framework that Postgres has, which is called the GUNK framework for your tuning knobs, you could actually extend that for your extensions also. In order to kind of use GUNKs for your extension, you would actually define in your C function, I'm using the language example of C out here, and define it in pginit, and use the similar way to kind of define new GUNKs for your extension. So in this particular example, what I'm doing is I'm creating a demo.param1 as a GUNK example. There is no requirement for you to use demo dot out here. But that has been kind of like a standard practice that I've seen people using, which actually is a good practice. So when you see that GUNK parameter, you know that this is very specific to this extension being used as such. So when you kind of see them in your list of variables for your database instance, you realize like, hey, this is tied to this particular extension. So once you define this variable, how do you kind of see that? Now, one thing I've mentioned, right? Let's go back to the basics. If you load a dynamic shared library, the first invocation would load it, and then it would make it available. But for things like the tuning parameters and everything, you want them to be available right from the beginning. In order to make sure that they are available always, you have to preload them. So anytime you use like a GUNK parameter or anything that actually does something different, you would want to kind of start preloading that library anytime a backend instance is started. So in this particular example, I'm showing you, like, now that I've defined a GUNK parameter, I need to preload my library. And that can be done by adding demo to my preload library. So it's always loaded anytime a new backend is executed. Once you start doing that, you would start seeing your tunable parameters out there, which is show demo param1, and you can start using those variables in your functions and behave differently if you want, right? So now you have seen how functions are defined, how GUNK parameters are used. What if your functions want to use or execute more queries and do more consolidation work, right? Like, it's kind of like writing stored procedures where I want to do write my own queries, do a lot of digging, and then come back with an answer. So if you are writing in functions in a different language, Postgres gives you a framework called Server Programming Interface, which would give you more ways of running more queries from your functions itself. It's kind of like broken down into 4 sections. It gives you basic functions to run query. It gives you support functions to kind of like, get column names, get function field names and other things. And then also features for like allocating memory and freeing them up. And even transaction management, like if you want to do a little bit of rollback and restart an transaction. Mind you, when you are using any function, you are already in a transaction. So you never have to do a begin transaction because you will always be in a transaction. But this is more like you want to do a rollback and start a new transaction and continue from that point. It also gives you transaction management features out there. There is the list of functions available out there would change a little bit from version to version. So you have to look for the versions that are supported for this particular one. The example that I'm going to use is more from the Postgres 12 example out there. But the demo I'm doing, I'm not going to go through every line of it, but I just want to show you and highlight. Like, what it would allow you to do is, from your function, I want to make other call and run more queries from it. So all I do is do an SPI connect out there. And then I define, I'm going to run a select version query because all my functions are about versions. So I'm defining like what query I want to execute the query, process the query, and get the value out from it. And what I'm doing in this particular sample is, in addition to my demo version, I'm also showing you the Postgres version along with it. So that's the change I'm doing out there. So in this command, what I'm doing is I'm kind of concatenating both the versions together and giving out that version name back. This is just an example to show you on how you can run more queries from your own functions as part of extensions, right? So redeployed, executed. I'm claiming that this is not changing the behavior much, even though it is, and I'm reusing the same version for it. But bear with me for that one. I'm just showing you a demo on how you can run queries on it. So when I reinstall it, typically in order for the new function to be visible, you need to start a new session, because when you start a new session, it creates a new background process, loads the new library up. You won't see that in your existing sessions already. So when you create a new session and run the demo version, now it actually returns a modified one, where along with my version, it is also giving the Postgres version behind the scenes.
If you're preloading, you have to actually restart.
If you're preloading, then you have to restart. OK, yeah, correction. Right. So what I've given you is just enough food for you to kind of think about how you can write more extensions. There are some advanced readings you can do on this topic. You could actually access shared memory and start using the shared memory as part of your extensions. You can also start using Postgres hooks. Hooks are great if you're modifying existing behavior. If you want Query Optimizer to do something different, if you want some function to do something different, you would use hooks and override those functions. So till now, we have talked more about adding functionality. Hooks gives you a way of modifying existing functionality also as part of that. And the same thing is you can use them for your triggers, right? Trigger, in the end, basically calls similar function. So within your function, you have access, like, is this a trigger before, or is this a trigger after? Is it a delete trigger? And you can use that to kind of write your own trigger functions in different languages as such. So those are the things you could do on top of what I have explained on that. With that, I'm getting to my end summary of that. So what my goal was to teach you about extensions, how to use them, how to develop one, how to think about upgrades of an extension, and then the power of extensions to kind of write your own new function. And part of my team, we actually manage about 60+ extensions for Postgres. So it is something that I see is a wide ecosystem of Postgres beyond the core Postgres that gives a lot of new functionality on top of the core. It kind of varies from spatial data to new languages to new functionality. Like lately, I've seen more and more people writing functions specific to ML learning, string manipulation, KNN type of functions, and so on. So it really gives you people a way to kind of add functionality that they want to core Postgres. So with that, if there are any questions, I'll be happy to answer them. If not, thank you for coming out here. Thanks.